Hello, 8th graders, and welcome back to my channel. So, what you're going to do today, there is a video on page 27 describing kinematic diagrams. Kinematic diagrams, long story short, it's just a way of diagramming motion over time. So kinematic is a fancy word for that. You're going to be asked to do an exercise. You'll see, like on exercise 29, for instance, you'll have this very picture. And you're just given some information about it. And among those things, every tick mark on the horizontal axis, of course, is going to represent 1 minute of time. Every tick mark on the vertical axis will represent a kilometer. So our protagonist here, Jane Grey, she starts at point A, which we can see really represents 3 kilometers. So when we are asked how far she has traveled to get to this point, we're reading over here, you are not going to write 5.5 kilometers. That would not be correct because she only started at the 3 kilometer mark. Think you can figure out how to answer that first question? Good, I hope so, because again, that's what it's asking here for this first one when it says, how far did she drive in the first 5 minutes? Then you can, now from this information, you can figure out how fast she was going in terms of kilometers per hour. Now, of course, 5 minutes is not a full hour. You're going to need to determine, what fraction of an hour is that? Well, I mean, if 1 hour is 60 minutes, I can use simple unit analysis to say 5 over 1 times 1 over 60. 5/60ths, right? 5/60ths, yeah, that's 1/12 when I reduce that. Yeah, so 5/60ths of an hour is 1/12 of an hour. So you could treat this as, 1 hour is 1/12 of an hour here, okay? And how far did she go? Pretty clearly, when you subtract these two, you're going to get 2.5 kilometers. So if it's 2.5 kilometers in 1/12 of an hour, how many kilometers is that? You should be able to figure that out. So, but as for the rest of the diagram, as we move along on this thing, understand that a flat line here is indicating no motion. Stopped, right, for almost 1.5 minutes. Backtracks. Has stopped again for a minute. Kind of speeds up a little, and heads on back to where it was. Stopped again for a minute. Moves on to point R and then stops again all the way to point S, and that's when the experiment ends. So you're asked a series of questions on exercise 29. Among them are velocity questions. What's the average speed between certain minutes? You may be asked how far, for instance, maybe we say how far did she travel between minute 12 and minute 15, and again, you'll simply look where Q is, looks to be about 5.5 kilometers. And point R is, 6, 7, 8, 9, 10, looks like roughly 10 kilometers away from point, wherever the 0 point is on this thing. So yeah, we could easily surmise that this distance was 4.5 kilometers. If another experiment starts at some other point, for instance, if her name is Jane Grey, let's say Bud Black starts at the 7-minute mark, from point 0, and he starts going at a nice constant rate of travel, something like this. I mean, I can look at this and see that, this individual is traveling 1 kilometer every 2 minutes, right? Because this is crossing the 1, crossing the 2. But the point is, this person is not going to be at the same place at the same time. If, on the other hand, we started earlier or increased the speed that this purple-lined person is going, then perhaps we would, in fact, meet up. Understand, I hope. So, that's kinematic diagrams. Please take a moment to watch the video on page 27. Then there's several pages of information about the history of pi. It's rather interesting stuff. They do all that because it's a setup to the very, very last kinematic problem, which is based on circular motion, which circular motion, of course, that definitely relates to pi, doesn't it? Okay, so, but that's it. That's all I want to talk about for today. Complete through exercise 33. You should be starting on roughly, it's exercise 29 is the kinematic diagram. So go up through exercise 33 and read those pages between 25 and 30. Be good for your parents. Have a great weekend, and I will see everybody on Monday. Bye-bye.